your task is on this page is to create a table of input and output values. So create a table of x's and y's so that when this function was graphed, it would show itself to be a linear function. So there's a few different approaches that you can do. One thing that you can do, if you'd like, is you can think about what you already know about how x's and y's behave in linear functions, and you can try just by using the table to create x and y values so that this will be a linear function. And that's kind of a fun strategy. It's kind of like a puzzle, right? If you're not sure how to do that, or if you choose x's and y's and then when you graph it, it doesn't look linear, you might want to try a different strategy. So another strategy that you can use to do this assignment is you can choose your own linear equation in the beginning. So, for example, don't steal my example, because this example belongs to me. If you want to use this strategy, choose your own equation. So my equation is not for you to use. So you can't have mine. This is mine. So, and I'm serious. If you do it this way, do your own equation. So, but what you could do is you could start with a linear equation in slope-intercept form. And then what you're going to do is you're just going to plug in some different values for x. So in my case, I want a mix of positives and negatives. So I'm just going to choose some numbers. I'm going to choose some positives. I like to do 0 because that's my y-intercept. And then I'm going to choose some other numbers. Okay, so these are my inputs, right? And then what you do is you just substitute these numbers in for x. So instead of that x there, we're just going to plug in these different numbers. Okay, so the first number that I'm going to plug in is a -4. And 3 times -4 is -12. And -12 plus 2 is -10. So when I plug a -4 in, I get a -10 out. Now I'm going to plug in, instead of a -4, I'm going to plug in a -1. My parentheses got a little messed up there. So I'm plugging in a -1. 3 times -1 is -3. And -3 plus 2 is -1. Continuing on, I plug in my 0, my 1, and my 2, and I'm going to get my values out. So 3 times 0 is 0, plus 2 is 2. When I plug in a 1, I get 5 out. And when I plug in a 2, I get 8 out. And now, no matter what equation you used, or what points you used, you're going to graph your values on this graph. So I plotted -4, -10. I plotted -1, -1. I plotted 0, 2. I plotted 1, 5, and I plotted 2, 8. Okay. Then what you can do is you can draw a line through your points. And lines go on forever in both directions, so I could draw more up here. but you get the idea. Now, if your points did not create a linear relationship, double check your work, because as long as your values here are linear, when you draw a line through them, it's going to resemble a line. It's going to be a line. So if not, go back and revise. And then the other thing you'll want to do is answer this question down here. Looking at your graph, how can you tell that your table represents a linear function? So a linear function. How do you know that this graph made from these points is a linear function? So you explain that here.